Hello everybody, how's it going today? Today I wanted to show you how to convert a quadratic from standard form, which is just ax squared plus bx plus c with a not equal to 0, to vertex form, which is just a times x minus h squared plus k, again with a not equal to 0. Now this process is known as completing the square, and it is notoriously difficult for students to understand. A lot of them end up confused, and I think oftentimes it's taught very procedurally, with little intuition as to how this whole thing is working. And sometimes even the geometric proof seems like a stretch. So today I wanted to showcase how to actually complete the square using algebra only, and a clever little substitution trick, but more so just by analyzing the structure of these two expressions and how they relate to one another. So let's do that. I say we start with the goal in mind. Let's start in vertex form and work backwards and get our quadratic as close to standard form as possible. Because if we have a quadratic in standard form already, if we can identify how h and k relate to a, b, and c, then we'll be able to write our quadratic in vertex form every time, given that we have it in standard form. So let's do that. Let's compare how these two forms are similar. Let's start by expanding or distributing this binomial here. This is x squared minus 2hx plus h squared plus k. Let's distribute this a. We end up with ax squared minus 2ahx plus ah squared plus k. Okay, great. We have fully expanded this, so now we ask ourselves, how is this similar to ax squared plus bx plus c? Well, hopefully you noticed that these coefficients here should match. If we want to view this as being in standard form, then this right here would be our b, and this right here would be our c. It's important to remember that a, h, and k are just numbers, so the sum of these two is just a constant. Okay, well, if we know that negative 2a should be equal to negative 2ah should be equal to b, then maybe we can isolate h so that we can express h in terms of a and b. Let's divide each side by negative 2a. Therefore, h equals negative b over 2a. Okay, great. We also know, and let's actually box this result. We also know that c, I'll do this in a different color, how about yellow? C should be equal to ah squared plus k. Well, what do we know about h already? Oh yeah, it's equal to negative b over 2a. So let's replace that with negative b over 2a and square that quantity. All right, let's simplify what we can. Negative b over 2a all squared is just b squared over 4a squared. And we know that an a in the numerator and denominator can cancel, leaving us with b squared over 4a plus k. Remember, our goal at the beginning was to write k in terms of a, b, and c. Let's isolate k. Let's subtract b squared over 4a from each side. Okay, and we have that k equals c minus b squared over 4a. All right, we have h and k. Great. Now let's go back to our original expression and replace h and k with what we found them to be. We found that h is equal to negative b over 2a So let's replace h with negative b over 2a. And we also found that k is equal to c minus b squared over 4a. I'll write this in a different order to preserve how this is traditionally shown. So this is minus b squared over 4a plus c. Let's simplify a little. Let's actually move this down here. So our final result, we end up with a times x negative b over 2a is just positive b over 2a. All right, great, and we did it. We were able to take a quadratic that was in standard form, show how to work backwards, and relate it to vertex form. We showed how these two structures are similar, and we simply solved for h and k, which allowed us to perform a substitution, giving us a guide of sorts on how to convert a quadratic from vertex form to standard form. Oh, sorry, standard form to vertex form, given that you know A, B, and C. Why don't we check to make sure that this truly is correct? Let's distribute and see if we end up with ax squared plus bx plus c. Let's simplify this. Here we go. Let's start by distributing this binomial. X squared plus 2bx over 2a plus b squared over 4a squared minus b squared over 4a plus c. Let's distribute a. We end up with ax squared plus 2. Actually, these twos cancel out. abx over a plus b squared, we'll say ab squared over 4a squared minus b squared over 4a plus c. All right, some more things can cancel. ax squared plus bx plus b squared over a, 4a minus b squared over 4a plus c. Oh, and would you look at that, these two terms cancel. So we end up with ax squared plus bx plus c. Okay, so now we have definitive proof that this is indeed equivalent to a times x minus plus b over 2a squared minus b squared over 4a squared plus c. All right, we successfully completed the square, and we didn't use any geometry whatsoever. We just used simple algebra and our logic and intuition. A lot of times when you're setting up to prove something or show why something's true, you want to start with the end in mind. So that's how we knew to start with our vertex form, right? And we ask ourselves, hey, how is this similar to standard form? And we simply work backwards, get the two structures to match, and then see how the terms are related. I hope you found this video useful, and have a great day.